Studio.
Yeah, we can see your R.
This is the continuation really of last time. We got pretty close to finishing, but there were a few things we missed at the end. But I'll give a brief recap, just quickly run through what we went over. I'll briefly go what we went over last time and then finish that off. And we should do that in quite a bit of, have quite a bit of spare time afterwards to go through some other stuff. So I've just gone and created a few other things that we can look at, things that I think are worthwhile thinking about, little sort of tricks, I guess, or not tricks, but things that I've encountered and had to troubleshoot in the past. So just get started. So you're going to need two packages, tidyverse and gapminder. Gapminder is a data set, and so we need to load that in as we did last time. And just giving a recap of last time. So ggplot, as my drummer pointed out, GG is the grammar of graphics, which really just means that any point can be expressed from the same set of components. So a data set, a coordinate system, and a set of geoms. And really the point I tried to emphasize last time, that this is essentially just layers. So you're just building up from this as initial sort of data set. So we'll just quickly go through that again. If you want to follow along. If you don't have to. We've already done this, so it's okay. But it's really up to you. There will be some new stuff later that we can do as well. So just to give you an idea, actually, a reminder. So the gapminder data set, country, continent, year, life expectancy, population, and GDP per capita. So here we have this data set, gapminder, and we're going to assign a set of coordinates to it through this mapping and aesthetic function, where we have GDP per cap on the X, on the Y we have life expectancy. Those first two layers, we end up with nothing really. We should have an X and Y axis.
I think it says that GDP per cap can't be found. Is it spelled properly?
Maybe not. And voila. Thank you, Legana. And so from this, we have, again, just emphasize our data set, we have a coordinate system, and then we have a set of geoms, or within this context, we have this geom point function. Building on that, we then look at other arguments. So we can take the same sort of structure and apply some other things to it. So I think next we look at year and life expectancy, which is this super ugly plot where essentially we're connecting all the points, and so we can't really derive any information from that. But we can have this other argument that it's the by argument. So it changes the geom so that it's by country, and so we can see that each line here represents a different country. They went over other arguments, so there's things like color, alpha, shape, all that kind of stuff. It can help with visualization and exploration of data. And from there, we went and we looked at multiple geoms. So this is sort of emphasizing that layering idea within ggplot, where we can just add another layer. Which also highlights this other point, whereas in ggplot, so anything in this first function is then applied to the geoms below, because it is this sort of layering thing. But any argument you put within the geom function is going to be specific to that geom. So we can manipulate this so that we just have the color for the lines as opposed to the points. We also need to make sure we use the aesthetic function. And then from there, I think we went on to transformations, then the statistics. So we can take this first one again, which really isn't showing us a great representation of the relationship between the two. So we can transform this, and there are a number of different ways, but the one I showed was so we can scale the axes by a log value, in this case log 10, and this maybe can help us explore relationships a bit better. We can then add a line of best fit with GM smooth. This context, we're going to use LM method. So essentially line of best fit, a little bit of shading with I think either the standard deviation or the standard error. I can't remember which, but if you check the vignette for it, it'll tell you. I did mention last time as well, you can add an equation using ggplot. I didn't go into it last time, but just to give you, I guess, a quick ggplot stat grade line. You can add the equation to it, and that's super handy for, I think, if you need to publish this figure, right? There are ways or arguments within this where you can manipulate how the formula is structured, or even the data that you're using for the formula. We then went into multi-panel figures, and the first thing we need to do was subset. I'm just going to copy this back on my notes because I don't bother rewriting it. But essentially, this is where I introduced the tidyverse. So we can see in the subset, there's two ways of getting the Americas from the gapminder data set. I really wanted to emphasize this point because, you know, the tidyverse I find is very intuitive. Just to run through what's going on. So in the first one, we have this gapminder data set, and then the square brackets allows us to access information from that data, and before the comma being the rows and after the columns. And so here we have the gapminder data set for the column continent, anything equal to Americas. That's what we're trying to subset it by. The reason I like the tidyverse version is because essentially how you say it is how you write it. And so it's extremely intuitive. So if you gapminder data set and you want to filter it by continent, Americas. And that was really the point I was trying to get across in that with that last time. And this sort of allows a bit more functionality, I guess, which I'll highlight in a second. But really, we're here just taking a subset. So let's plot this. And to make it a multi-panel figure, so we're going to facet here using facet wrap by country. And eventually, we'll have this multi-panel figure where we have the relationship between. Can everyone mute, please? This relationship between life expectancy and year across different countries, right? Another thing I pointed out here was being able to manipulate text on the plot. So we can actually just because we can't really read it yet. There's this theme function. To make it a bit more readable. And that should give us, yeah, so a nice multi-panel plot, multi-panel plot that's readable. And then the last thing I showed here was sort of integrating this tidyverse idea or concept with piping and plotting. And one of the main strengths of, I think, the tidyverse, which I was talking about last time, is the use of pipes. And essentially what we can do instead of creating all these intermediate objects like Americas, so I was saying last time, you can imagine when you're doing a a large project and you have lots of data sets, this starts to fill up and it becomes a bit of a pain in the ass to navigate, especially like maybe you're only going to plot Americas once. And so why do you need to create a new data set for it? And at the same time, the more data you get in there, the slower R gets. Like it's going to be slow to open and close, and it's just a pain in the ass. And so what we can do is take this initial code, and then we're just going to pipe that directly into ggplot. All we have to do is get rid of this data argument, because the tidyverse and pipes are smart enough that anything that's being piped is going to be piped into the first argument of the function. If you need to put it somewhere else, like you say, if the data argument is actually the last argument. In this context. And that should work. Cool. And that's pretty much everything we did last time. So really the idea last time was, layers. I think that's the main point. Really, I said ggplot is sort of like it's functionally layers, but I think also like how you can conceptually think about building up your plot is like layers. And I'll sort of go into this a little bit more in a minute. But just in a way that, we're having these arguments, there's ways we can manipulate the plots, and the best way to tackle it is one step at a time. Cool. So the next thing that was in the, before we move on, were there any questions? Or I'm going to assume that's a no. So we're going to move on with the rest of the software carpentry workshop, or jumping into some other stuff. So the next thing we need to look at, we need to look at modifying text and then exploring plots. So the last 2 points in the software carpentry workshop. And so for the modifying text, we can just reuse the same example. So we have this plot here. We don't have a title. Maybe we don't like the X and Y axis labels. We can also maybe add some color. So we don't like the X and Y axis labels, and we also don't like the legend title as well once it comes up country. And there's an easy solution to this. There's actually a few ways you can manipulate the text on the ggplot, but for these sort of simple arguments, the labs function is the way to go. And it's really straightforward. So you have title. You're going to have X, Y. And then for this last one, for the legend title, it's going to be specific to whatever you're using. So in this context, we're using color. But obviously, if you had fill, you'd be using fill, alpha, whatever the manipulation there is. So, we can give it. And then maybe for the axes, we just want it to be in capitals. For whatever reason, maybe that's what the journal wants. Who knows? And that's definitely the most straightforward way to start manipulating text or modifying it. But there are a few other things you can do. So there's this function called theme, which is super handy. And it allows you to modify both text and also other elements of the plot. So we can say we didn't want to see. Let's say we want to get rid of the title down the x-axis. So we can. And I think this is the theme I found not recently, but just I find it's a really good way of cleaning up your plots. If you're someone like Kevin and you don't like the gray background, you can get rid of the gray background. If you don't like the axis.ticks, you can get rid of those as well. So essentially the theme just allows a lot more extended sort of manipulation of the plot to make it more visually appealing, which is probably highly subjective, but maybe there's some things at a particular journal, how they want you to plot it, right? But it's super handy, super cool. And there are also like themes, like you can download a template from someone else and just copy and paste their theme. So everything's a white background, all the ticks are removed. It's extremely handy. There you go, like Legana is saying, Kevin. And I don't understand the hate against the grey background. I really prefer the grey background. I don't like how, if it's all white, to me, everything just like disappears into the space. And yeah, no. So I strongly disagree with Kevin there. But, you know, each to their own. So exporting plots was the next part. ggplot makes it super straightforward. There is just a simple function. Thanks, Kevin. ggsave. So ggsave is pretty clever. You can assign, so we can assign this a name. And then we can have file name, which is going to be a file path, right? So we can just have, and then the file extension for the type of file that you want. And then you would have plot, right? And you could have plot equal to America's plot. That's one way of doing it. However, like I said, ggplot's kind of smart. Hadley Wickham is very smart, the guy who wrote the Tidyverse. And ggsave will also, if you just run the last plot, instead of assigning a plot to this function, it'll be smart enough just to take the last plot that you created. So we can just take a particular plot. And it'll save this because it's the last thing to rank. So if we go to the directory, see there. And I don't know if this probably won't pop up in your screen, but if you're following along, it should pop up here. If it's not, just give us a shout. It will help you find it, but it should just be in your working directory unless you assign like a full file path. So you have an outputs file folder. It's easy enough. Yeah, so you can do it either way. You can assign this a name, or you can just run it like this. It's really up to you. But maybe if you're trying to save all your files at the end, you can assign them all to a particular, plot, and then save them all again. Really, it's just a preference. You can also change the height and width here. You can spell it. So super straightforward. I would show you what that does, but I think because I'm sharing my screen, actually. So you should be able to see that, I think. And so we can manipulate this as much as we want. Hopefully you can see the plot. If you can't, someone yell at me. Because I think I'm sharing the actual screen as opposed to the window. But what you need to be aware of is as you change the height and the width is literally of the plot. And so, okay, maybe not that big. As you change the size of the plot, the size of the text won't change. And this is an issue I actually ran into myself because I don't know why I made the plot so big. And then you get to let's just go 6. So I was giving this as an example. My bad. I don't have an outputs folder. But I guess the point that I'm trying to get across is that although you change the file size, the text size isn't going to change. So if you try to make your plot as big as possible with really great resolution, the text size won't change, and so it'll be completely out of proportion. And so you'll go to publish this massive, beautiful, high resolution picture, but you won't be able to read any of the text. So it's a pain in the ass and just something to be aware of. There we go. Like that. Mine wasn't that bad, but it can still be not great. So just be aware of that. I'm sure you'll see it. But yeah, something to be aware of. And the last thing we're going to do from the software carpentry workshop, there was a little bit of a challenge. I think I manipulated it a little bit. But it'd be great for everyone to have a crack that wants to have a crack. Essentially, I want you to generate box plots. So GM box plot to compare life expectancy between the different continents during the available years. There might be more than one way to do this, but I have my way. And so it'd be great if everyone had a crack. And then maybe once you're done, drop it in the chat and just give you all a few minutes. And bonus points if you can remember how to remove axis information like the title, text, and ticks. So go for it. And Maxine, I want to see yours first. That'd be good. And does, I think the error usually implies it's not installed, right? You just try installing again and then maybe loading it. I think Lorenzo could be right as well. But if you're loading the tidyverse, it should be sweet. Just like Evan. All right, while Maxine is getting that sorted, she can show us her plot after I put mine up. This is how I would have done it. Kevin's. Yeah, it's fair. I do like the grey background. It's probably the best part. Cool. Well done, Kevin. You're really progressing, mate. I don't know why I'm running this out. I got it written in front of me. I didn't mind with a little facet so you could see the distribution across years. All that grey, so much better. How did everybody else go? Looking at you, Ashton and Maxine, really. Did you get ggplot working, Maxine? Boring is a good start. It's not sad. Blank plot. Are you getting, do you know what the error is this time? Yeah, maybe send your code through like Legana said. And we can all be super critical of it. We really mean. Also, on a separate note to everyone, I apologize that you're all looking up my nose. My laptop has the camera on the bottom of the screen. It's a design flaw, but it also meant that I got my laptop for $1,000 cheaper, just so everyone knows. Sorry. I might, if it's all right, Max, I might keep pushing forward. But we can chat at lunch. Do some more fun. Or just paste your code in and Kevin or Legana can have a look. Yeah, I like setting up my ivory tower. All right, so that would have been the end of, or it is the end of the software carpentry workshop. But again, I said I'd go into a few other things, just, you know, I guess why not, right? And I mentioned last time the Star Wars data set, which is way better than Star Trek. And I thought we could play around with that a little bit. And I kind of posed this question, if all the worlds went to war, who would win? I guess I'll show you the data set. So you should all have this data set. If you just write, because it's part of the tidyverse. And so when you install tidyverse, it should be there. And if it's not, I'm so sorry. But this is what the data set looks like. So you have all the characters, height, mass, hair color, all these things. And then you also have like vehicles and starships. I was like, oh, that'd be cool. We could figure out who's got the most starships and such. But that got a bit convoluted. And so I thought, oh, well, let's think about it differently. So if all the worlds went to war, who would win? But, you know, if they had to fight with hand-to-hand combat, that was my idea. So really the people or the planets with the biggest individuals are probably going to win that fight. And so the question kind of evolved to who's got the biggest person and then who's got the biggest army, really, in cumulative mass. And there's a few concepts here I wanted to go through, one of which is adding text to the plot. So not manipulating the axes and stuff, but actually adding text based on the variables. Also manipulations of different arguments within ggplot, so within particular functions. I did mention this last time, like you can divide the axis by 1,000 or whatever to change. So you're going, you know, from kilograms to grams or something like that. And then also just integrating tidyverse and creating grids as well. So grid it's kind of like a facet, except you have multiple plots. And so if you don't want to waste one of your figures, so if you're publishing in a particular journal, and let's say you can only have 3 figures and you want to have this beautiful summary figure that actually has 3 or 4 different plots in it, a grid can help you to do that. I would argue that it's probably easier just to plonk it in a PowerPoint or something like that. But if you create a template, again, kind of like themes and all that, if you have this template ready to go, then it's not too bad. But we'll run through that today anyway. So the first thing we're going to look at to answer this, who would win, you know, in hand-to-hand combat, we're going to look at individuals. So essentially, who's got the biggest player, who's got the, you know, the biggest alpha that's going to squash everyone else. And so we're going to use some tidyverse type coding, and we're essentially going to explore the relationship between, well, we're essentially going to look at the mass of the individuals, right, the size of them. And so, oops. So the individuals will be under name. You can see, we're going to look at mass. And because we want to know what homeworld they belong to, because really that's, you know, that's what we want to figure out, which homeworld's got the biggest dude or dudette. We're going to color that by that as well. And this is the plot we get. And sorry for missing the chat. Right. And this is kind of an ugly plot, but this is what we get. And we're going to add a few different things to this just to make it a bit clearer. But we can see that whoever belongs, or whoever this is huge. And so we can assume, I think it's a very safe assumption that whoever has this big dog is going to win the war. But we can do a few different things just to clear this plot up and also decipher who that is. So we can change the scale just to make it a bit clearer to see the differences between different individuals. Kevin, you're wrong. It'll be very obvious when we see who it is. And like, yeah, this is, I guess this is also highlighting another issue that Legana posted about, and I'm sorry I didn't get back to you, Legana, in the Slack channel, because I have no idea how to do it either. But when you get over like 20 individuals, and then the color becomes like a gradient instead of individual colors, it becomes a bit of a pain in the ass to decipher between levels that are in close proximity. But yeah, but now we can see a distribution a bit more of, you know, who else is sort of in there. But we're also going to tidy this up a little bit more. In the essence of time, I might just copy and paste this. And then the important part here that I wanted to show was, we can see that whoever, well, I mean, this person, just to say, comes from Malhata, but we don't know who that is. And then I want to know who that is just based on, you know, we want to know who the biggest person is essentially, or biggest alien. And one way of doing that is we can use this thing called ggplot2. Now, ggplot2 is another function where we essentially can assign text to the plot based on a particular variable. So we can literally use ggplot2. It's an aesthetic again, right? And we want the label to be equal to their names. And so with that, we'll get the name of all the individuals on the plot. So we now know that that's Jabba. So everybody knows Jabba the Hutt, right? Jabba's huge. So now we know who they are and what country they, what homeworld they belong to. But then this is also really messy. It's pretty well, gross. So another thing we can actually do here, which is sort of the manipulation, I guess, of arguments or functions or variables within the plot, is to apply something that Natalia introduced us to the other week, which is if-else statements. And there's actually an if-else function, which is like a shorthand for this, and it's super handy, and I use it all the time, and that's why I wanted to show it today. And within this context, it'll be a little bit like this. So instead of, we don't just want everyone's name, we only want Java's name on there. And I find this super handy if like we have an outlier, you want to outlier or highlight why that is an outlier by a particular variable, but you can label that variable, but only to that individual point, and then it becomes obvious why that outlier exists. That's the context that I've used it in my own work anyway. And so we can use this else function, and then we have name. So the first part of the if else function, the first argument is geez, what's the word? I can't think of the word, but I'm just going to write it out and then it'll make sense. And so we have Java's name. The condition, that's the word, sorry. Brain fart. So the condition is if the name is equal to Java, then we want the label to have the name, right? Otherwise, blank. And so then we'll just have, it comes up. Now we only have our outlier label. And again, I've just found this super handy. We can also like move this around just so it's not right on top of the point if you want. And there are other arguments within this function, I'm sure. No. Cool. And so now we have the plot. We know who the biggest dog is in the universe or solar system or whatever it is, and they belong to this home world. But when you start thinking about it, maybe cumulative size of the army actually matters a little bit more, not just an individual. And so now I'm going to introduce something that's a bit more tidyverse-esque. And so this is creating a summary. We haven't done this, but again, it's something else that I've come across a lot in my own work. I'm also in sharing data with my supervisors or other authors, and I'm just trying to represent, instead of making them look at this big, ugly data set, or even a small table with a summary, I've found it beneficial to plot, I guess like summary data. Like for me, like it's clinical stuff. And so the averages or the distribution of probiotic supplementation or something like that. And so I thought I'd just quickly show an example of that. So we're using Star Wars again, obviously, because in this context, we're looking at size of the army, so the cumulative mass of all the individuals. And so we're going to introduce two functions here, and the first is group by. And so we want to group the data by homeworld. That's as simple as it is, right? Grouping by homeworld, and then we want to summarize it. Again, this is highlighting how great tidyverse is, like how I say it is how it's written. We're going to summarize by creating a new variable called total mass, equal to the sum of the mass, right? So this is individual's mass, obviously, and this is a new variable that we're creating. I'm also going to put in another little argument here. And this is just telling it to ignore NA values. So when it's doing the sum, otherwise it's just, if you have an NA value in your calculation and you get an NA output, and that's not what we want. And so we now have this new summary from this initial data set with homeworld and the total mass of each homeworld. And again, using tidyverse, we can redirect the summary straight into a plot because I'm never going to use this summary again. You know, I only want to plot the cumulative size of the armies. I don't actually care about the data. I just want to visually see it. And so we can just redirect that. But I'm going to start by filtering just to get rid of zero values because who cares about those homeworlds, right? So let's say greater than 0. Now, the obviously the aesthetics are now in relation to this new data that we've created. So it's not going to be the names from the Star Wars data set. So we have this new data set, homeworld, total mass. So we have homeworld versus total mass. And I'm also just going to pop, you know. And I'm going to use GM call. And now it's pretty obvious, except we can't read the name, that there's one planet that has an excessive value for its total mass, right? Just to clean it up so we can actually see which planet that is. Let's get rid of the legend because I mean it doesn't really help us at all. So another way to get rid of legend position is equal to none. So that's another little handy trick. Cool. So we now have this plot that tells us that again, now Hutta, a little bit off center, has the greatest cumulative mass. And then obviously Jabba the Hutt is the biggest, fattest thing in the solar system. And so we have these two summary plots, but maybe, you know, we want to show it all in one figure. And so we're going to introduce this other package, or this other package called grid extra. And so grid extra just allows us to combine multiple plots into the same figure. It's a good tip from Legana. I'd do the same when I have a lot of values. So when I've like, for me, it's like microbiome, so plotting the distribution of taxa. Obviously, there's a lot. And even if you subset the top 20 or 30, it makes a lot more sense to have it at the bottom. In a context like this, though, I was showing total mass a couple of times. So yeah, grid extra. There's a function called grid range, and essentially we just need to so we're just assigning these plots you know, to an object, and then we can just pass them into here. And it'll plot them all together. And obviously it's not very tidy. It's kind of ugly. But I guess it gives you some idea that you can combine these into a single figure. You can also, there's a lot of arguments within this that you can use. So you can define the number of columns, the number of rows. So if we change it to the number of columns, which is going to be even worse, but just to give you an example, you can manipulate the structure or the format of the grid. There you go. If you want to get super intricate about it, I think it's layout is the argument. But I'm pretty sure it's layout, and you can assign like values to the layout to structure the plot in a different way, or the grid in a different way. We don't have time to go through that today, really. But essentially, if you think about this as like imagine if you had 4 plots, right? Or 3 plots, let's say. If you think about this with like 4 vectors, so you have 1, 2, 3, 4, you can assign values. So the plot 1 is like 1 and 2. And so it occupies this total space here. And then plot 2 occupies space 2, and then plot 3 occupies space 4. And so your most important plot should be much bigger than the other two. And you can play around with that quite a bit. So definitely check out the grid extra like vignette. It's super helpful. And Legana has suggested another package called Patchwork, so have a crack at that as well. And then, all right, so the last thing was a little challenge, just to bring everything sort of together. So for this, I guess, thinking about the idea of layering, right, and breaking this up piece by piece, create a figure using genome point that shows the relationship between mass and height, colors individuals that are greater than 200 centimeters or less than 100 centimeters. And I just realized that might be using a concept that we haven't actually introduced, but we'll go through it. Changes the size of the points based on birth year, and then labels with name the shortest and tallest individuals. Right? There's a little hint there, but instead of the hint, I might just give you the first line. And there's probably a couple of ways you can do this, but just want to filter out rows that have NA within mass, height, and birth year. So not across all columns, just for these three, so, the ones that are of interest to us. So please have a crack at doing that, and then we'll give you like a few minutes because we're running low on time, and then you can run through it all. It is a little bit more complicated. I was hoping to have a bit more time for this, but that's all right. Have a go.
Kevin, Jacob, can you perhaps explain again what was in the individual mass graph? What does the V just and H just means? It's just for the size, or
It adjusts the location.
at the location of the graph of the legend.
In
or
which
of the
plot was it?
In
It'd be of
the
the text.
individual mass.
Oh yeah, so it was so it'd be the name. So you have like the genome point, and then the text will be like height adjusted by like 1, and then vertical adjust, horizontal adjust. Yeah, so
Okay.
horizontal adjust by 1, and then vertical by 1, sort of thing.
Okay, thank you.
That's right. That's a good point by Kevin. I was just looking at as well, if you were working, but if you're listening, Patchwork by Legana does look great. And like what I was talking about before with like the layout concept in grid, it looks a lot easier in Patchwork. So definitely have a look at that. Seeing as we only have a few minutes, sorry if you didn't get through it. It might be a bit convoluted. But yeah, we'll just get cracking. So plot x is equal to mass, y is equal to height. Let's just start with that. We'll start adding stuff. So that's the first thing we have, which is kind of not very informative and pretty ugly. Might just and then we need to start adding other things. So the first thing is color those individuals that are greater than 200 centimeters or greater than 100 centimeters. What we can do here is we know we have a color, where we're at, our argument, and we want height. We want it to be equal to height, but we only want to color those individuals that are greater than 200. And that's the thing I said we might not have introduced before, so I apologize. I shouldn't assume that. So we want height to be greater than 200 or height less than 100. We now have the greatest and the smallest values colored. And it can be informative in some contexts. Like if you're doing a volcano plot or something like that with the RNA-seq, I'm sure that would be beneficial there. Then what the next thing was, change the size based on birth year. So the size argument. Cool. And the last thing was label with the name the shortest, tallest individuals. So we can use that GM text that we just introduced. Again, we only want to label specific individuals. And so we need to use an if else function again. So in this context, it's height equal to the max of height, right? That's the condition. We want when height is equal to the maximum height, or height is equal to the minimum of height. We want the name. Otherwise, we want nothing. And then we're just going to adjust that again, just demonstration's sake. And voila. It's a pretty ugly plot. Probably doesn't tell us much, but I think it was just a good exercise in trying to all those things together. So hopefully some of you got it. If not, sorry. But hopefully you all learned something. And that's all I have